Okay, so now let's think about the head and the node. If we're going to be using references, we need one to always be equal to the first node, and the next we can actually move as much as we like. We're not going to lose anything. Welcome everyone. Today we're doing something interesting. This is a problem given by Netflix in a coding interview for a software engineer position. Now, this one is actually very simplistic. I think I actually thought that I have recorded this before. However, it turned out that I never really actually placed it in YouTube for some reason. I'm not entirely sure what's going on, but I have a feeling that I have already explained this somewhere before. So let's read the problem and figure out a solution. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. I usually do not read them because nobody wants you to read in the internet, but here it's actually very short. That's why I decided to read it for you. Now, what this means really is that I'm going to do that. Can you see that good? I think you can. So let's say that this is going to be our linked list here in this current example that we actually have with green. And we are expected to be returning with black color now this list over here. What's actually important to note currently is that our things, our duplicates, are in a sorted list. So we shouldn't be worrying about sorting really because it's already sorted. We just need to traverse and actually remove this and end up with one or two. I believe that if you go down, you can see, oh no, it's actually, it's not telling you to do it in a linear time. Okay, it doesn't matter. So what can we actually do? So there are a couple of solutions for this. First of all, I can iterate the list nodes, right? The linked list that I get. And if I find the element twice, I can just put everything in a hash set, and then I can just traverse this hash set and make it as list nodes, which is going to be pretty easy, and just return the head of the list node that I have created. Now, this is going to be a proper solution if you actually go by that. But here we have something a bit more advanced that I'm going to show. Now, let's say that we have this array over here. So I'm just going to put this linked list in the black square. Now I'm going to work with, I think black is going to be nice. Yeah, I think that's okay. It doesn't bother my eyes. So the first node that we're going to have is going to be our head, which we are going to be returning. Whenever you're working with linked list, you always want to return the head reference because this is what is going to be used by the server in order to traverse the list that you have already built. So always keep a reference here unattended. So you just want to create the reference and not touch it at all. Now I'm going to create another reference over here and I'm going to call this node. Very simplistic. I'm just going to go with node. And now this reference, if I go and I switch node to be equal to .next, for example, and I switch the number 5 here, then I switch the number 3 over here. In theory, when I return the head, which is pointing at the first list over here. So let me go with, I'm going to go with red just to show you. When I'm returning head, since head is pointing to the first element, I can iterate it and I'm going to see 1, 5, 3 in my backlog. And I'm going to see that because I have already traversed it with another reference. So this is very important to note. What we can do here in the solution is the following. Now, if I have a head here, because obviously I want to store one, and let's say that I'm going to have a node as potential candidate, right? So it's going to be pointing at 1. Now, I'm going to check if this node over here, and this is going to be n.next, if it's not equal to no, because you know that in the linked list currently, in order to denote that it's ending, we have no. I'm going to check if this node is equal to this node. If that is the case, it means that I have a duplicate, right? So I'm going to check them obviously by value, because if you're checking them by reference, chances are that they're going to have a different space. They will have a different space. So I'm going to check their values. Now, if 1 and 1 are standing over here, I have the same nodes. That means that I have a duplicate in my sorted list. This means that I need to change the next node of this. Shouldn't be this right over here as it is, but rather I'm just going to change it to 2. Then I'm going to check and you're going to see that .next is going to be equal to no, meaning that at the end of the list, So I'm just going to return 1, 2. Keep in mind this is difficult, but you're going to see it in code. Now I want to go down just to show you with, actually it doesn't have the example that I want, but I'm going to draw it over here. Let me just draw very, very quickly a different array. So I'm going to have 1, then I'm going to have 1, then I'm going to have 1, and then I'm going to have 2. So how are we going to traverse this? So again, I'm going to have the first and the second one pointers, right? So this is going to be 1 and 2. 1 and 2 is going to be pointing at the same stuff. So obviously I'm going to check if 2 is equal to 2 point next, which is this one. If they're equal, I'm just going to switch number 2. So I'm going to place number 2 here. Then I'm going to check if number 2 and number 2 dot next is equal. It is, so I'm just going to switch these. Then I'm going to check, okay, now I can see that these are equal again, right? So I'm actually going to place this 2 right over here. And finally, I'm going to say, okay, now they're different, so I'm going to move my node right over here. You're going to see it in code right now. So let's actually go. The first thing that we have been talking about is to create the list node head, right? You have to keep the head which we get here and just create another reference that's going to be equal to head in order to traverse the list. So this is going to be done by the following. List node is going to be equal to head. Currently, we can pick whatever we want over here. It doesn't really matter. You can pick 1, 2, 3, or 8, 3, something like that. I'm just going to go with node or item. Yeah, I'm going to go with current item. So this is going to be current item. I think this is going to be better. So, oops, sorry for this. If I go down, you can see that my range of nodes is from 0 to 300. So I'm not going to put any unnecessary if checks. I'm just going to put everything into a while loop statement. So I'm going to say while my current item is not equal to no, and my current item is not equal to no. Current.next. It's very difficult to talk and think at the same time. Good. Now I'm going to open and close, and I'm going to show you what I want. So first, I want to know that these are constantly available to me. I want to know that I have these constantly available, because if I have these, obviously I cannot have any more duplicates over here because I have no as a final element. So this is going to be no defined in JavaScript and CSharp no. So I do not need to worry about it. That's why I'm checking, all right, if my current item is not no and my current item.next is not no, then I'm going to try and do some shenanigans, some magic. This is also going to cover my list range, because if it's 0 or if it's 1, obviously it's not going to go into this while loop, and it's just going to, you guessed it, return head. We're going to be working with current item, and we're going to be returning head, just as we said in the start of the video. So now here comes the interesting and the tricky part. I need to check if my current item dot value is equal to my current item dot next dot value. So this is actually the main thing that we need to write. I want to be sure that this value over here is not equal to this value over here. What are we going to do if these values are equal? I'm just going to take this bracket over here, and I'm going to point to this. The way I'm going to do that is I'm going to say current item dot next is going to be equal to current item dot next dot next. And that's it. You're going to see that it's an if statement, so nothing else is going to happen this round. This is what's going to allow me to actually cut every single one that I have. And of course, let's write the else statement and finally visualize it once again. I'm going to say current item is going to be equal to current item dot next. This is how you traverse a linked list. And finally, we're returning head. Once again, let's go a little bit. I'm going to press a lot of enters here just to give myself a writing board. Control D to open it, and let's see what we have. Oh, actually, that's not a good thing, because I wanted this to be seen. So something like this is going to be the perfect solution for me. Something, yeah, just like this. So let's actually go with ones. 1, 1, 1, 1, 1, and I'm going to have 2. Actually, that's too much. Let's just go like this. So currently, I have the current item. This is going to be the current item. And I also have head, which I stored because I actually return it here. This is untouched. So I'm going to check if my current item dot value, so if this value over here is going to be equal to this value over here. Sorry for this. It seemed like we had problems with the license again. I'm not entirely sure what's happening because it's doing it for quite some time, but it doesn't matter. Let's just go straight to the problem again. And the graph is going to be a bit different. Sorry for that, but I didn't expect, because I bought a full year license, so it should be good. But all right, let's go with head current item. And because I said that we're going to be returning head, should be untouched. And let's see, current item value, if it's equal to the current item dot next value, this dot next, right? So this is the next item. This dot next is actually going to be deleted, and it's going to be pointing to this item in the list. And in other words, I'm just going to say, okay, this is invalid now, and I'm just going to be pointing at this item over here. I'm not going to do anything, and current item still stays right over here with head. In the next iteration, because otherwise, if we're not moving anything, the while loop is going to be infinite, so we're having a next iteration. I'm going to check if my current item value is equal to the current item dot next value. So if my current item, keep in mind, current item is still here, so it is still here, and it's still equal to this value. What we're going to do, we're going to remove dot next, right? So dot next is going to be equal to dot next dot next. So I'm going to remove this one over here. This is going to be invalid, and I'm going to point right over to. These are my references now. In the next loop, you're going to see that my current item dot next is actually equal to no. So we have reached the end of the list, and I'm just going to return head. In the first iteration, this iteration that we did, we can return current item because we have not changed its position. We just changed the references. So it's going to work, but usually we're just going to, once we do not find a duplicate, for example, if we have a lot of 2s, then I'm just going to switch the current item to be equal to 2. And then I'm going to do the example once over again and again until I actually get to the end of the list. So currently we are finding a no item, meaning that we are definitely at the end. And I'm just going to return head. Head is pointing to 1. So here is interesting. Head is pointing to 1. But ones dot next position is not pointing to the ones that we actually skipped. Rather, it's pointing to the 2. So the server is seeing the following. It's seeing 1 and 2. So with 3 ones, we have actually destroyed these and we have returned 1 and 2. So let's actually put my words to my actions and see if it's going to work. Run code, use test examples, and also, just for fun and giggles, I'm going to do the following. So I'm going to do this, and I'm going to return current item, and I say, oops, that it's going to work. Based on the examples that we did, it's going to work with current item here. And it didn't. All right, why it did not? Oh yeah, it's not going to work because we're actually having current item with noise, but it's actually not changing. Yeah, so actually here is the problem, and this is actually very good that we actually did it because it's very... All right, here is the problem, and it's actually very interesting. So let's write it down because I had a slight problem in my explanation. So again, the current item is going to be here. The current item value is equal to this one. So this next is going to be removed, and we're going to point to this one. Same thing is going to happen. So this next is going to be removed, and we're going to point to 2. But we're not going to end because current item currently is not no, and dot next is actually 2. So dot next is not no, and we're going into the else statement, and we're actually saying current item is going to be equal to current item dot next. So that is why I have failed my bet over here, and I received 2 rather 1. So obviously I had 1 and 2 as an output, as you can see, expected. Output is over here because I'm not returning head, I'm returning current item. And current item I actually changed in the else. So current item is currently 2, and after 2 we do not have anything. So sorry for losing the bet, but it's going to work if I type head over here. Let's run the code. And this time I bet again, and you can see it's running. So finally, let's just submit the solution. As you can see, I did this 1 year ago, and here are the results. Thank you for watching, and if you have any questions, leave them down below. Oh, actually, final thing is to be talking about space and type complexity, because I forget them quite a lot. Now, this is going to be big O or big O-N, and of course, time complexity. This is going to be the time complexity. And this is going to be space. Space. The first solution that I actually begun with in the intro, where I told you that you can do a hash set, you could put a lot of stuff, was going to have the same time complexity, but it was going to have O-N space. Because obviously we're using more memory in order to create the hash set. So yeah, I always seem to forget these, but I'm going to change because they are important. Thank you for watching. And if you have questions, leave them down below.